Hello, everyone. I'm Travis Gibson. I'm a Perl dev at Perceptics. I'm also a Raku enthusiast, and lately I've been doing audio-related programming. My topic today is USB devices, how to drive your own. So when we think about USB devices, we're usually thinking about marketing terms, things like high speed or super speed or plug and play. And the other thing we usually think of is all the physical connectors that we've got. There's a lot of those. Um, so the way it works under the hood, there's 650 pages of spec just for USB 2. And this covers just about everything that you could possibly want to cover, including even things like marketing, as well as the things listed here. Thankfully, we don't have to cover most of that. You only really need a little bit of the hardware, some of the software for working with it programmatically. So today I'm going to cover USB messages, capturing USB messages, and then I'm going to talk about an example where I have done so. So the first thing is that USB devices have a ton of different descriptors. You may have seen these if you look at LSUSB in Linux, or look at the Mac System Report or the Windows device properties for your USB device. Every single USB device has a device descriptor. There's only one per device. It contains things like the vendor ID and the product ID, and it contains a number of configurations. These configurations, you can have one or more. Only one of them can be active at a time. These give different properties for the configurations, such as the speed of the USB device or the power consumption. And each of these configurations has a number of interfaces. The interfaces specify a class and a subclass. For example, an HID device like a mouse or a keyboard, or an audio device or a mass storage device. Each of these interfaces forms a single feature of the device, and each of these interfaces has a number of endpoints. These endpoints have addresses. The endpoint with the 0 address is always there, and they have a transfer type, which I'll get to in just a moment. This forms a large tree structure that every USB device has. So for endpoints, these are sources or sinks of data. They use zero-based indexing and has a minimum of one endpoint, which is endpoint 0. These are connected to the software via pipes. There are two different types. There's a message pipe, which is bidirectional. It's host controlled, and it contains formatted data. It's sort of like UDP, but not quite the same. And then a stream pipe, which is unidirectional. It's host or device controlled, and it's unformatted, and this feels a little more like TCP. There are some differences between those as well. So for data transfer, there are 4 types of data transfer. There are control transfers, there are interrupt transfers, isochronous transfers, and bulk transfers. So I'm going to go into a little more detail here. Control transfers are used in command and status operations. So usually these go to endpoint 0. There are 3 stages to these. There's a setup phase, a data phase, and a status phase. Sometimes, depending on the request, these data phase can be skipped. Interrupt transfers have a guaranteed latency and detect errors and retry if something happens. And this is akin to interrupts on, say, a CPU or something along that line. Isochronous transfers have guaranteed access to bandwidth with bounded latency. They have error detection but do not retry, and there's no guarantee of delivery. Bulk transfers are for large bursty data. They do have error detection. They have guaranteed delivery, but no guarantee of bandwidth or latency. A little more on control transfers. There are multiple parameters. The first one is a request type. It's 1 byte long. It is a bitmap, which describes things like which direction the data is going to go, the type of the request, and the recipient of the request. Then you have the request, the value, and the index. these are all numeric enumerations that are specific to the particular device you are using. There's a number of standard requests that every USB device must implement. There's a number of class-specific requests that every USB device of that class must implement. And then there are vendor-specific requests, which are unique to the device itself. The value and the index are two arbitrary parameters for these requests. There's also a length parameter, which sets how big the buffer for the data that you are sending is, and the data buffer itself, which is either data to send or a buffer to receive data into. So the catch, of course, is that since some of these requests are vendor specific, if you want to write a driver for a device, any vendor-specific requests must be reverse engineered, which brings me to capturing USB packets. So I have done it. I've attempted to do it on Windows unsuccessfully. I have not tried it on a Mac, but I have managed to make it work on Linux. For Linux, you use USB-Mon, which is a kernel module, and Wireshark. On Windows, you use USB PCAP and Wireshark or Microsoft Message Analyzer. Or alternatively, which is what I did, was you load up Windows in a virtual machine and you capture the USB packets in Linux. On Mac, it seems to require High Sierra or later, libpcap and Wireshark. So here's an example. This is an audio box I recently got. It's got a vendor ID and a product ID listed there. The basic audio I/O worked in Linux, but the more advanced features are vendor specific. One of those is setting the clock source. Clock source is basically a setting that lets the audio device synchronize to either itself or external sources. If you use an external source, you can synchronize multiple audio devices together, and that lets you use each of the audio channels on all of the devices without getting clicks and pops. So for this particular device, the request type is 0x40, which I'm going to specify as to device. A request of 5, which is set clock. A value of either 0 or 1 for the internal or the word clock input. An index of 0, this parameter is not used. And a length of 0, no data is actually transferred. So basically, in order to set this up, the simplest way is to use libUSB, which is a cross-platform C library for communicating with USB devices. It has a simple synchronous API, which I have worked with, and a more complex asynchronous API that I have not gotten my head around yet. This is very useful for prototyping, regardless of whether you want to eventually write a kernel device driver or something else. So for the basic flow for libUSB is fairly simple. You initialize it, you enumerate your devices, you loop through all of the devices to grab the correct device. Once you have the correct device, you have to, of course, free the list. Then you open the device to get a handle. At that point, you can start sending messages, setting configurations, doing all sorts of things like that, whatever you need to do. Once you're done, you can do the teardown, which is close the device descriptor, and then close down libUSB. So of course, being a Raku enthusiast, I immediately wrapped a lot of this in Raku using native call. So for synchronous transfers, the only things they support are the control, bulk, and interrupt. The isochronous transfers must be done asynchronously. This is a limitation which has not affected me yet, as I've only needed to use the control interface so far. So here is a sample of some libUSB code in Raku, which is wrapped around libUSB. This is basically a very simple low-level wrapper. The most complicated section of this is the get device line, which I have wrapped the enumeration, listing, and selection of device all in that one function. So the beginning of this is simple. We set up a bunch of constants, which I showed you before. Then we create the device, we initialize libUSB, we get the device, we open the device, we allocate a buffer, and then we control transfer to the device. Then we close the device and we exit. I do not actually have a live demo because it would be very difficult to show you the device actually changing its clock source. And that actually ended sooner than I thought it was going to. So the resources I used here, USB in a nutshell, is a very comprehensive and very simple to understand description. They cover pretty much everything you would want to know about it in an easy to read format. The libUSB documentation is also very useful for setting up your devices and going through them. And then when you need to get more advanced or go through the specifics, the USB specs are at usb.org. Any questions?
If you have a question, you can raise your hand or unmute yourself. We have a question in the chat. What made you choose Raku for this project?
I was doing some prototyping and I find it very quick to use Raku for just whipping something up simple. Even if I have to do a native call binding for it, it flows better with my way of thinking.
We have another question from Raku.
You just did?
Sorry, I didn't quite hear that.
Would it be possible for you to release that as a Raku module of live USB hack or something?
Yeah, I'm planning on doing a little bit of cleanup on it and then releasing it probably in the next day or two.
Is there any way to get notified when it's up, just so I know where to look for it?
The weekly newsletter for Raku should have that whenever it comes up. That should come out on usually Mondays.
The last one is, I asked before, if you've tried running, and it should run reasonably well, slapping Raku on a Pi. Because
yes,
the interface, it should be easy to play with the pins and play with the USB.
I have not attempted to play with the GPIO pins or any sensors or anything like that. But what I have been doing is I have an audio related project to audio over IP, and that actually, with the latest Pi 4 and the gigabit Ethernet, has enough bandwidth to actually do low latency streaming of audio over a network.
Would you be willing to try working and getting, because just getting out of the marketing thing, it would be kind of neat if we could stick a module out there, some sort of little package that anyone who wants to play with a Pi could use a Pi 4 and use it for that, like the audio over IP or something. It would just be a nice way to attract people, and watching the way you were doing this, it seems like a neat way to get tinkerers into it. And Raku's a beautiful language because that C interface is exposed. It's built, like you said, it's easy to prototype in it.
Yeah. I probably could work on some of the lower level stuff in GPIO pins as well. The project that I mentioned is still is still a huge work in progress. It involves a whole bunch of other things that it's talking to. So it's not done yet, but I am working on it.
Well,
but yeah, I think the
I'd be willing to help.
Okay. I'll talk with you after this then.
Okay.
Oh, and I think I saw somebody asking for slides. I will attempt to figure out how to do that. This is I am using a little bit of it, doing a little bit of an experiment here, testing out a presentation software that uses restructured text. I can link the restructured text for this presentation immediately if you would like. And I'll put that in the Slack.
Do we have any more question? I don't see any. Michael, maybe?
Oh,
No, thanks. It's cool.
I did see one more question go by. Yes, the audio I/O worked almost out of the box. Initially, I had to add a hack to the tweaks table in the Linux kernel, but aside from that, it just works like you'd expect. The more advanced features of the device were not exposed.
Okay, thanks, Travis. Thanks for the talk. I'm going to stop the live stream if we do not have any more questions. We still have a few minutes if needed, but okay, thanks, great work, Travis.
Okay.
Oh, one more question. Hans Bruce, you can unmute yourself.
I asked this in the chat a second ago, but were there any other features or things of this audio device that you were able to get working on Linux?
I have been working to figure out the mixer interface. That is rather complicated, and I still haven't really gotten to the point where I feel like I even know how to capture the packets that are coming in. I'm not entirely sure how they're doing that configuration setting. So I haven't really gotten anything else working quite yet, but I did manage to get the word clock setting into a Linux kernel with some code that I wrote. Eventually, I'm planning on getting that into the Linux kernel upstream.
There was another question in chat that I'm interested in too. Is there any USB support in Perl 5?
I have not looked into it. I would assume there is something because CPAN is quite comprehensive, but I have not looked into it at all.
There is, but you have to use XS, and it becomes holy hell to make it work. Whereas in Raku, because you've got the native call built in, getting the interface done is just orders of magnitude easier.
Hans Bruce, do you have a question?
Oh, no, I'd already asked. Did I forget to lower my hand?
My bad.
So I guess just as a general comment, thank you very much for the talk.
Rob, if you have a question, you can go.
I do. I'll try and make it quick. You said that there are certain functions that all USB devices must implement, certain control functions, and also some for the class. Where is that documented? You said there's a lot of documentation in the official USB specs. Is there something that's, I don't know, I guess easy is not the word, but is there something that's accessible to just quickly see what you have to do or what is available across these devices?
Off the top of my head, I do not remember, but there was a set of class documentation that I did come across. I believe it was also on USB.org. Since I was trying to implement things that were outside of the standard functions, I did not look into that very much.
Okay, thanks.